everyone, thanks for joining this short video on using this Google Colab notebook to generate a mass spectrometry fragmentation tree and simulated GCMS spectrum for a molecule of your choosing directly from smile strings. So this is a very short notebook. Obviously you can add to it if you wanted to, but I'm just going to start it off by installing the dependencies, and you can see the name of the dependencies in the code cell. And you can see that we've just done a pip install of RDKit and NumPy. And these are the main dependencies that we're going to be using for this. And then you just run the mass spectrum fragmentation tree cell, and that will generate a text box where you can input your smile string. So you could delete this and put in your own smile string. I've just put one here as an example. And then you can select the mode, so you can either do a retro-synthetic fragmentation mode, which will split the molecule up based off of synthetic chemistry steps. So if I just run through that, you can see that it's identified this nitrogen here as the bond cleavage point. So for example, it's basically identified that you could do a SNAR or a book called Hartwig coupling there. Equally, you could set to mass spec like, and that will generate cleavage of the bonds based off of electron spray ionization and fragmentation. So it will give you lots of different possible fragments, including the mass ion over here, 312. It'll give you the mass charge ratio, and it'll also give you the fragment. And you can scroll across here. There's a few different fragments you could have, and some of these are based off of bond cleavage. And in the last cell, you can put in your smiles again. You can select a positive or negative electron spray ionization mode. So let's go for positive here. And the label mode, you can select ion, mass charge ratio, or both. And you just press play on this cell, and in a few seconds it will generate a simulated GCMS spectrum that you will be able to compare to your experimentally determined spectrum, and it will hopefully help you to identify your products. And that's been generated, so we can zoom out a little bit just so we can get a bit more of the spectrum here. And you'll notice that some of the peaks are in blue, so the peaks are automatically labeled, and the blue ones are the more common ones. So you have mass plus sodium, mass plus acetonitrile plus proton, etc., mass plus isopropanol. So obviously it depends on what solvent you've used here, but it gives you a few different options. And also you'll notice that if you hover over individual peaks, it will show you a little thumbnail of the potential fragment at that mass. So this isn't guaranteed, but for example, if this was your molecule and you selected the peak at mass overcharge 312, then you would see the mass plus proton peak. And same here for mass plus DMSO plus proton 390, and 2 mass plus acetonitrile plus sodium plus proton, etc. Okay, so you've got a simulated GCMS spectrum here, relative intensity on the y-axis, mass charge on the x-axis. And say you wanted to report this data, you can just run this cell, and it will automatically write and download a CSV file. So it gives you the smiles for the fragment, it will give you the peak name, and you also have the mass and charge ratio there. And you can double click on this, you can open it in Colab like so, and then you could click on mass to charge, and you could organize in terms of mass to charge value or peak name or smiles like that. Okay, so yeah, this is obviously a useful thing to have in the lab. You can run it on your mobile because it's run through Colab, so you don't need any local installed software. You could use this. Obviously, I'm not encouraging mobiles in the lab, but If you were just gramming a coffee and you want to know roughly if you've made your molecule, then you can use this Colab notebook. So that's everything for this video, and thanks for watching.